Hello, BC Calculus. This is Introduction to Series. Because of the COVID virus, again, you guys are only going to be doing very few of these series, but I'm going to give you the entire sheet, front and back. It's attached to an email that tells you about this video. And I just want to go through what you actually do need to know and don't need to know as far as this year's calculus test goes. So, the first video after this will tell you what it means to converge and diverge and give you some examples of that. I remember back in topic 47 we did some integrals and we saw whether those converged or diverged, and then we'll talk a little bit more about that as well. So once you print this out or write this out on a piece of paper, if you don't have a printer, put a little star by this one. The geometric series is one of the things that they are going to test this year. So this is one of the things you learned in pre-cal last year, is a geometric series. So geometric series is when you multiplying the same term by the same thing, or a term by each consecutive term by the same thing to get to the next term. So for example, if my first term was 1 and I multiplied that by 2, I'd get 2. Multiply that by 2, I'd get 4. Multiply that by 2, I'd get 8. So that's a geometric series. Okay. What you need to know is it converges when that ratio, in this case for my example here, my ratio would be 2 because I'm multiplying by 2 every time. That'll converge when the absolute value of that ratio is less than 1. And it'll diverge when the absolute value of the r is greater than or equal to 1. In my case, my ratio is 2, which means this series 1 plus 2 plus 4 plus 8 is going to diverge because 2 is greater than 1. And then the sum, and you need to add this here, the sum is equal to a1 over 1 minus r. And I'll correct that before I send it out. So this is one to memorize, and you should have done this in pre-cal last year. You probably don't remember it, but the sum of a geometric series is a1 over 1 minus r. But this is only valid when this actually converges to a sum. So this is only valid when r is less than 1. Okay. Put a star by this one. This is P series. So this one's pretty easy to see because it's 1 over n to P, where P is the exponent or the power on that n term. That will converge when P is greater than 1 and diverge when P is less than or equal to 1. And then an alternating series, that's a pretty easy one. That's when the terms alternate back and forth between signs. So all right, so the term that makes it alternate is either -1 to the n, or sometimes we'll use -1 to the n plus 1, but it's easy to see because the terms will go positive, negative, positive, negative, positive, negative. So it'd be like 1 minus 2 plus 4 minus 8 plus 16 minus 32, etc., etc. And an alternating series converges when the terms get smaller in absolute value and the limit as n goes to infinity goes to 0, which we'll talk about more on. All right, as far as the rest of these types of series goes, you don't need to know power series, but a power series is a type, or Taylor series and Maclaurin series are types of power series. Taylor and Maclaurin series, these two formulas here look very, very scary, but they're not really that bad at all. As you'll see, it's one of these things that is actually really easy. People tend to make it harder than it needs to be. And the only difference between these two is a Maclaurin series is always centered at 0, but a Taylor series could be centered anywhere. But other than that, these two things are identical. Okay. So those are the series that you need to know about. And we'll, like I said, we'll make videos over all of those. What you don't need to know is you do not need to know alternating series error or Maclaurin error. I remember I told you guys there's 4 approximations that you do in BC Calculus. First one is a tangent line approximation using the y minus y1 equals m parentheses x minus x1. Second one is a Riemann sum or trapezoidal approximation. Third one was Euler's approximation, where you make the table of xy, dy dx, and dy is equal to dy dx delta x. And then series are also approximations. If it's approximating something, there's always some amount of error involved in it. So for instance, if it's actually 1.9 and I approximate it to be 2, then I'm off by 0.1. but they're not testing that stuff this year, so you do not need to worry about errors. And then these are some of the different tests that we can do on different types of series. And the only one they're doing this year is the ratio test, which is the bottom one. So you're not doing the nth term test. The integral test is actually what we did in 47. So if the integral converged, then that summation converged as well. Or if the integral diverged, then that summation would diverge as well. And it's used on a p-series, but again, that's not something they're testing. You can do a direct comparison test or a limit test. The nice thing about the ratio test is it always works, except if the power is 1, but usually they're not going to give that to you on the test. So we'll do a bunch of the ratio tests. This is kind of the default test. It's not the easiest one to do because it takes a little bit of time, but once you learn how to do one of them, they all follow basically the same pattern. So they're following the same formula to do that. So we'll do the ratio test as well. And that is it as far as the backside goes. So you're going to learn a few of the different types of series, and you're going to learn how to do the ratio test to determine where that ratio is going to converge, or in some cases diverge as well. Okay, so I'm going to send this out to you. Start to memorize the ones that we starred by. It's not going to make a whole lot of sense until we actually get done with them or go through the notes for each one, but I wanted to go ahead and send this out to you today.